Hi everyone, this is our ninth lecture, Cosets and Lagrange's theorem in Unit 1 groups. In this lecture, we are going to discuss about some important theorems in cosets. So this result is very useful to proving the Lagrange's theorem. It's also a very important result. The theorem statement is there is a one-to-one correspondence between any two left cosets of H in G. So we are going to choose two left cosets in H. We are going to prove that one-to-one correspondence between them. Proof: let H be a subgroup of the main group G. Let AH be any left coset of H in G. Let us take AH is the left coset of H, and also H itself is a left coset in H. So therefore, we are going to prove one-to-one correspondence between H and AH. For proving one-to-one correspondence between two sets, we need to define a function between them and to say that particular function is 1, 1 and on 2. So any particular two set is one-to-one correspondence between them. Function defined between that particular two set is 1, 1 and on 2. So for that, we are going to define a function between H and AH. Let the mapped function f between the set H to AH is defined by f of H is equal to A star H. We are defined this function f of H is equal to A star H for all H belongs to H. So for proving one-to-one, we are going to take f of H1 is equal to f of H2. This both H1, H2 belongs to H. So f of H1 is what? We are defining f of H as like A star H. So therefore, f of H1 is equal to A star H1 and f of H2 is equal to A star H2. So then, according to the left cancellation, we can cancel out this left side A on both sides. So finally, we are getting H1 is equal to H2. We are taken f of H1 is equal to f of H2. We are proved H1 is equal to H2. Then we can say the function, that defined function f is 1, 1. So let us move on to the another proof. F is onto. Let us consider any arbitrary element x belongs to AH. Then x is equal to A star H. Of course, x belongs to AH means we can take x is equal to A star H. In the previous slide, we are defining the function for h, f of h is equal to A star H, right? So therefore, f of h is equal to A star H. In the above step, we are taken if A star H is equal to x. So finally, we are getting f of h is equal to x, right? So therefore, the function is of course onto. So hence f is bijective function of x onto ah. So therefore f is 1, 1 and onto. So therefore this is set up a one-to-one correspondence between h and ah. Hence the proof. With the help of theorem 1.1 and 1.2, we are going to prove the very important Lagrange's theorem in the next lecture. Thank you.